Here we've been presented with a reaction. So H2 reacts with CO and this produces an alkane. So C₈H₁₈, could be a whole number of different things, and H2O. We've been asked to calculate the mass of C₈H₁ produced from the reaction. Okay, so how am I going to approach this? Well, the question tells us that CO is in excess, right? And what are the implications for this in terms of our specific reaction? Well, the implications as far as the stoichiometry of the reaction at least is concerned is that we can reasonably assume in this case that the H2 is going to be the limiting reagent, and therefore we can effectively use this mass to work out the mass of the C₈H₁ that was produced. So how are we going to approach that? How are we going to go through this process? Well, if we consider C₈H₁ in the context of the moles mass and molar mass equation, right? So mass is equal to N moles multiplied by the molar mass, MR. Well, in this question, we would be able to work out the MR from the periodic table, but with regards to the moles, we can't easily work that out directly. We would need to rely on kind of a pathway of using stoichiometry, moles calculations to get to what that value of the moles is. So that's what we're going to do. So looking at the mass of the H2, which we've been told, if we can figure this out, we can use the amount of substance ratio once determined to figure out, well, what's the mass of the what's the amount of substance of the C₈H₁, and subsequently figure out what the mass is. So let's go through the process of figuring out what is the amount of substance for the H2, right? So the first thing I'm going to do is, well, we're going to need to rearrange this equation. So originally, as you see there, we've got the mass is equal to the moles times the molar mass, right? I'm going to need to make the moles the subject. So I'm going to divide both sides by the molar mass, MR. When I do that, on this side at least, you see the molar mass is going to cancel, and we get the moles is equal to the mass divided by the molar mass. So if I write that again, moles is equal to the mass divided by the molar mass. So let's figure out what the molar mass is in this instance. So H2, relatively straightforward. It doesn't require any kind of complex, hydrogen, you've got hydrogen here. The relative atomic mass is 1. The molecule we're looking at is H2. So we're looking at what is the MR of H2, right? So that's going to be equal to, of course, the relative atomic mass of hydrogen, which is 1, multiplied by its occurrence in H2. So that's times 2, which of course is just going to be 2, right? So straightforward maths. And so with that in mind, we can say that the moles is equal to 28.85 divided by 2. And so, I invite you to have a go at working that out, but if you do that division, you would find that that is 14.425, and that's going to be in moles, right? Now at this stage, what can we do with that to figure out the amount of substance for the C₈H₁? Well, let's first establish a comparison ratio. So moles of H2 as a ratio compared to the moles of C₈H₁. Now here's where the equation, which is a balanced equation, right? So here's where this becomes very important. You see we've got 17 here, and the coefficient here, well, it's not necessarily a visible coefficient, but because there isn't, I mean, the coefficient of course is going to be 1, right? So the coefficient is 1, and in this case, given that, we can say the ratio here for every well, we're going to have a 17 and a 1, and the implication is that for every 17 moles of H2, we're going to have 1 mole of C₈H₁, right? And therefore what this effectively means is that the moles of C₈H₁, if we're trying to figure that out from the moles of H2, is going to be equal to 1/17 times the moles of H2. Okay, and so we actually have that value, right? So that's going to be equal to 1/17 times 14.425. This is going to give us the moles for the C₈H₁, right? So if you do calculate that, what you should find is that you get 0.8485294, right? So that's going to be in moles. And well, if you go beyond this, we have been asked to work out the mass. So we were not asked to work out the amount of substance. Specifically, we're looking for the mass, right? If we refer back to this equation, which we had here, as I said, initially we didn't have a figure for the moles, right? And we had to go through all of this process to figure out what the actual moles were for the C₈H₁. We actually now have the moles, right? We have that. But this is still a question mark. But as I said, this can be worked out quite straightforwardly from the periodic table. So let's go through that process. So we're looking for the molar mass, so MR of C₈H₁, right? So the relative atomic mass of carbon here, as you can see, is 12. And for hydrogen, of course, as we discussed, is 1. So in setting this up, we're going to have to do 12 multiplied by the coefficient corresponding there, which is 8, plus 1 here, multiplied by coefficient corresponding there, which is 18. Okay, and well, if you work that out, you will find that you get 114, right? And that's going to be in grams per mole. Okay, so we've worked that out. What we also need is so we have both of these now, right? So we've got we had this before worked out. In this case, we've also actually got this is also worked out. So we just need to plug in the values, multiply them by each other, and we're going to be able to get the mass. So what we can say now is to say, therefore, the mass of C₈H₁ in this particular case is going to be 114 multiplied by the moles we figured out, so 0.8485294, right? And if you do that, what you should find is you get 96.7323516, and that's going to be in grams, right? So this is a mass figure that we've been able to calculate. Now, as the final stage, we're going to look back at our question and confirm what it's actually asking us to do. So the question specifies, okay, calculate the mass of C₈H₁. So we have calculated the mass, but it does then go on to say, please give your answer to a maximum of 2 decimal places, right? So we do also need to make sure our question fits within that parameter, which, as you can see, currently it doesn't quite fit within that yet. So we do need to look into, okay, well, how can we make it fit? And, you know, in this case, you would want to round it. So that just rounds to 73, right? So 96.73, and that's going to be in grams, right? To 2 decimal places. Okay, so in this particular case, our mass of the C₈H₁ would be 96.73 grams.